In today's video, we will talk about central nervous system, a variety of receptors, and just kind of how those affect the body. So first, we're just going to talk about the central nervous system in this diagram and how it all kind of breaks apart. So first, we'll talk about the somatic nervous system. This is voluntary movement of the skeletal muscle. And this whole neuron is going to be myelinated. I think that's how you spell it. It'll be one neuron. Okay, we'll take a look over here at the autonomic nervous system. This will be two neurons because honestly it developed later evolutionarily. It breaks up into the parasympathetic and sympathetic nervous system. The parasympathetic nervous system we know as rest and digest. Okay, and the sympathetic is freeze, flee, or fight. And then now we'll talk about the sizes of the presynaptic and the postsynaptic neurons. So for the parasympathetic, it's going to eventually be very long for the presynaptic and short for the postsynaptic. Okay, and the reason for that is because it directly innervates the organ. Now, we need to remember that the presynaptic is always going to be myelinated. Okay, and that goes the same thing for the sympathetic. But the sympathetic is going to be a little different. It's going to have a short presynaptic and a long postsynaptic. And that's because it does not directly attach to the effector organ. Instead, it synapses earlier. Okay, that's kind of the basis there. I want to take a look at the different pathways that are taken by the parasympathetic and the sympathetic neurons. And so we'll first start off. It starts off in the dorsal root ganglion. I'm going to start here. It'll come out, and then it will synapse here in the sympathetic chain ganglion. Synapse is here, and then it will go to the site where it needs to go. And this turns into a sympathetic nerve, and that will target glands, skin, and blood vessels, really. Anything on like the very most superficial portion of your body. And then we'll have another one. Comes from the dorsal root. It's going to synapse again here. Oh. And this dashed line means that it's not myelinated. And this turns into a spinal nerve. And these innervate anything above the diaphragm. Okay? Okay, and then we'll have another guy here. So it's actually going to pass through the sympathetic chain ganglion and it will not synapse. And it's going to turn into a splanchnic nerve, and it will synapse in the collateral root ganglion, and then to wherever it needs to go. Okay. This next one, and this is all in the dorsal root, even though I'm not really doing a very good job drawing that. Oh my gosh, it's not going to synapse. It's going to go through the sympathetic chain ganglion, through the collateral root ganglion, and come to the adrenal medulla. And it will synapse there. And this synapse, I can go into more detail later, but basically we'll release acetylcholine, and then the biggest thing that's released is epinephrine, or EPI. Okay, that's kind of the gist we need to know there. Moving forward, we're going to talk about different types of receptors. So we have cholinergic and adrenergic receptors, and let's break it down into some subgroups. But the basic idea with cholinergic is acetylcholine. So any receptor that's affected by acetylcholine, and then adrenergic is so the receptors that receive norepinephrine, epinephrine, and dopamine. So we have muscarinic, which are actually G protein coupled receptors. So that's just the secondary pathway, and nicotinic right here. N1, you'll find that in skeletal muscle. N2 is what we'll find in the nervous system. Okay. I'll draw a diagram here in a second, and then we'll take a look at alpha 1, alpha 2, beta, okay? These are all G protein coupled receptors, so just know if I put this triangle there, that's G protein coupled receptors. Okay, and muscarinic, those actually go M1 through M5. Okay, we're going to talk about what happens when these receptors are targeted by these stimuluses. So we'll start off with alpha 1. We'll start off with this picture. So in the sympathetic nerve or pathway, right, we have a short pre and a long postsynaptic. Okay. Now right here, I'll blow it up. It's gonna look like this, right? Okay, acetylcholine, it's gonna be released, ACH, and we'll have N2 receptors here. That's my N2 receptor. And then that will depolarize this postsynaptic, and we'll have a BWOG. And then towards the end, it will actually release norepinephrine, epinephrine. So release norepinephrine. Okay, and what that does to alpha 1 is going to actually increase our IP3. And IP3 basically just releases calcium, so it allows for contractions. And that means that our eyes will dilate, and our blood vessels will actually contract. Alpha 2 isn't really talked about very much, but it will have a decrease in insulin secretions. Okay. Beta 1, 2, and 3, they're all going to experience an increase in CAMP, so cyclic AMP. B1 is going to affect the heart. B2 will affect the lungs. B3 will do lipopolis. Oh my gosh, it's going to break down fat cells. Okay, what we need to know about here with mainly the lungs, that B2 is greatly affected by epinephrine. Okay, and when that happens, the lungs will actually dilate, so it will cause bronchodialysis. Just write that out. Bronchodialysis. Okay, that's kind of the main things you need to know there. With muscarinic, We can take a look at this kind of chart we could draw out. So well, actually, I'll just draw it here. M odds will cause generalized sweating, but sweating is impacted by the sympathetic nervous system. Now, muscarinic receptors are receptors for the parasympathetic nervous system, and it does the opposite of the sympathetic nervous system. Okay. Yeah, so that's kind of the main things that we need to know here. Yeah, thank you for listening to this video.